Hey, welcome to Module 3, Lesson 5, where we will be using the identity and inverse to write equivalent expressions. Okay, we continue on this journey of writing equivalent expressions, and truly the reason is to emphasize how important it is to understand that expressions, equations, etc., can be written in several different ways that are all equivalent. So, in the sense the same, but may appear different. Okay, we are going to, and we already have worked with identity. Okay, and we've worked with the inverse, but we will continue to do so in this lesson in terms of equivalent expressions. Okay, well, here are the opening exercises. I'd like you to go ahead and do 1 and 2, and recalling the definitions of opposites, which we just talked about recently, and reciprocals, okay, which comes up over and over again. Okay, so go ahead and do numbers 1 and 2 and 3, because that asks about a pattern. This should be relatively easy for you, so go ahead and do that and then come on back. Okay, so here are those first two completed. As you can see here, temperature check, negative 12 degrees Fahrenheit. When he first checked it later in the afternoon, it had risen, or it rose 12 degrees, and you can see that over here. I started out at negative 12, rose 12. Okay, where do I end up? Well, I end up at 0, and the way that looks is right here. Negative 12 plus 12 equals 0. Okay, so the additive inverse. All right, 2 is the same. It just tells you to rewrite subtraction as adding the inverse. Okay, so instead of having 2 minus 2, which we all know is 0 already, we rewrite it this way as adding the inverse. We have our addition sign is added, and then our negative 2 is set aside in parentheses. Okay, down here, similar but different. We have lots of negative signs here, so of course we're going to retain that negative 4 there. Okay, but then, as we see, if we have a minus, and remember we've done our little thing there, it's a plus. Okay, so subtracting away a subtraction, or doing the opposite of subtraction, is adding. So that would be negative 4 plus 4, and that equals 0 as well. Yeah, well, the last question, I think that C asks, I must have missed something here. Let me look for it. I'm sorry, yeah, I had just forgotten I had asked you to do all of 1 and 2. So, yeah, so C just asks for the difference of 5 and 5. I'm not exactly sure what they expected you to do with this, but difference of 5 and 5 is 5 minus 5, or two ways to do it. 5 plus a negative 5, which are both equal to 0, of course. And then G minus G, again, it's the same thing with letters, okay, with variables. You take the G away from the G, or it's the same as G plus a negative G, which equals 0 as well. Now, this question here, number 3, it asks, what pattern do you notice in the opening exercises? And hopefully you notice the pattern is that the sum of a number and its additive inverse is equal to 0. Yeah, so the sum of a number, again, and this is something we've talked about many times before, but it doesn't hurt for some of us to hear it again, and its inverse, because evidently they want to remind you of this because it is coming up in upcoming lessons. Okay? Yeah, we know this. Okay, the sum of a number and its inverse is equal to 0. All right. So go ahead and do 4, and let's do 4. Okay, yeah. Let's go ahead and do 4, and I do 4 and 5. And then do 4, and then we'll talk about it. Okay, this was ridiculously easy, of course, again, but just making a point. Add or subtract, 16 plus 0, of course, is 16. 0 minus 7 is the same as 0 plus a negative 7. We're combining numbers here, so negative 7. And of course, negative 4 plus 0 is negative 4, and 0 plus d equals d. Okay? And the pattern, what pattern do we notice in parts A through D? The sum of any quantity and 0 is equal to the Castle battle. Well, it's like I forgot to pause the recording while I was reading this over. Hopefully, I didn't, hopefully, maybe you just went ahead and did it while it was running. Okay. Anyway, so if you read it, if not, if you didn't read it, I'll read it to you now. Your younger sibling runs up to you and excitedly exclaims, "I'm thinking of a number. If I add it to the number 2 10 times, and that means 2 plus my number, plus my number, plus my number, plus my number, and so on, then the answer is 2. What is my number?" Okay. So anyway, in this scenario, it says you almost immediately answer 0, but you become a little bit unsure. Could there be any other number that you can add to 2 any number of times? In this case, 10, and the answer will be 2. Any other number that can do that besides 0? And of course, the answer is no. All right, just a quick little number line, 1, 2, 3, whatever. Okay. And now, of course, 2 is represented by a, if we have a line here, that's 2, or it could be this little line segment here is 2. All right. The only way we're ever going to get it to stay there at 2 by adding the same number, okay, over and over again. Now we could do this by adding. We can get back to 2 by adding several different numbers, but one singular number, never. Okay, let's say that number was 1. It's going to go to 3, and then it's going to go to 4, and then it's going to 5, blah, 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 and so on. Okay, yeah, so let's just cut to the chase and say no. I mean, 0 is it. 0 is the king or queen when it comes to maintaining a number. Okay, that's the we call the identity property of 0. Okay, it maintains by adding 0 to any number. And again, this is in terms of addition. You maintain the identity of that number. Okay. Okay, just a quick discussion for a couple discussion questions before we move on to example 1. In problem 1, what is each pair of numbers called? Okay, I might have mentioned it already, but what is each pair of these numbers called? Number 1 here. Okay, like the 12 and negative 12 and the 12. and here better to see it here, the 2 and the -2, the -4 and the 4. All of those are known by the terms, one or the other. You could call them, of course, we can call them opposites, or, which we've been using more and more, is additive inverses. Okay? So again, just to know that we are going to continually use this vocabulary. And what is the sum of a number and its opposite, and its additive inverse? And of course, we know that is always 0. Okay? The sum of a number and its opposite, or a number and its additive inverse, is always equal to 0. And finally, what is so special about 0? Well, as we saw in number 5, in problem 5, 0 is the only number that when added with another number or quantity, the result is that other number or quantity. Okay? This property makes 0 special among all the numbers. Okay, 0 is very special. Mathematicians have a special name for 0, and 0 is called the additive identity. Okay, it's called the additive identity. They call the property the additive identity property of 0. So 0 itself is referred to as the additive identity. The property is called the additive identity property of 0. Okay, because like we had mentioned before, 0 maintains the identity of any number or quantity. Okay, I'm going to do, let's go ahead and do example 1 here, A through C. Let's do this together. The instruction here is to write the sum and then write an equivalent expression by collecting like terms and removing parentheses. Okay, so this idea of like terms, let's just continue to stress that, to please understand what that means, and we'll go through it right now. But again, I want to be able to use this terminology and feel as if you are understanding. Okay, so right here it just says 2 and. So what they're doing, they want you to, write a sum. Okay, so if I do 2 and, I'm just going to go ahead and replace and with a plus sign. So that's going to be 2x plus -2x plus 3. I can put those in parentheses. Okay, because these are 2 separate expressions here. We are actually adding those together. Okay, 2 expressions. All right. If we go ahead and do that, we can, and again, this is going to be a lot faster for you at some point, but just to know that if you use the associative property, we can put these like terms together. So we can put 2x, and then we can, plus -2x. Put those together there, and just leave the 3 by itself. And of course, we know the additive identity property of 0 is going to make this whole thing 0 here, plus 3, and our final answer is 3. Okay. Same here. Well, see, this is interesting. They want you to write the sum of 2x minus 7 and the opposite of 2x. Okay, which would be -2x. Now seriously, I know it may sound funny and I'm making a joke about it, but got to remember what these questions are going to look like, because they're going to ask you something just like this. Okay, the opposite of 2x, which is -2x. You have to know how to read these and translate from words into an expression with just numbers and variables. Okay, so again, if we did this and we wanted to go ahead and collect everything over here, we would have we could bring our 2, we'd have our 2x, and we can add our -2x to it, which is sitting at the end there, and of course we would then add the -7. Okay, we're moving stuff around, commutative property, associative property, moving order, changing order, moving location, okay? So what we're doing is right here, we're just kind of combining these two right here, and then we're of course leaving this -7 on its own right here, okay? And of course, this whole mess here equals 0, and then we still have a -7, so this is going to equal -7, okay? The same here, C, the opposite of 5x minus 1, okay, don't get confused with that. All you need to do is put a negative sign in front of that entire expression, and 5x, okay, so again, this is the sum we are creating. So we have that, and as you can see, we have these two, -5x, because, well, firstly, we should say what you can distribute this negative sign, which is going to make this entire thing here, this is going to be -5x now, and then it's going to be a +1, okay, because you are going to multiply that -1 by the -1 and get a +1. Okay, and then if we did it this way, a little bit easier to see, we could put these two together, and they of course are 0, and we are left with 1 only. Okay, so we've used commutative property, distributive property, all kinds of properties, and finally the additive identity property of 0. We have an answer of 1. Now this exercise 1 is intended to be done with a partner in class, and as it says here, with a partner, take turns alternating as reader and speaker. The speaker verbalizes how to rewrite the sum and properties that justify each step as the writer writes what is being spoken without any input. At the end of each problem, discuss in pairs the resulting equivalent expression. Okay. So what they're doing is they're just trying to get you to verbalize what is happening. Again, this whole idea of being able to explain what you're doing, why you're doing it. Real important if you could find somebody to do this with in your house, or do it with your parent, teacher. That would be super. I guess research has shown that when you say something as you're doing it, that's really helpful to be able to speak your way through it, write your way through it. Okay, but for now, we'll just have you go ahead and do A and B here. Okay, and again, what you're doing is you're writing the sum and then writing an equivalent expression by collecting like terms and removing parentheses whenever possible. Okay, so you are doing that. Do it in a few steps. Don't just look at it and do it. I can look at this one right now and know the answer, but go ahead and do it in steps, because like I had mentioned in class this past Monday, it's not as much about getting the right answer, but as doing the process correctly. So go ahead and work on those and come on back for the answers. Okay, well, I actually went ahead and did through E. Okay, so maybe you did as well. But here we go. So A here, again, just writing it is probably one of the most difficult parts to think about here. So -4 and 4b plus 4. Of course, you write it out, and that just and part just means addition, like we've done before. Okay, you write it out, and then you have you went ahead and used my any grouping, any order idea right here, associative and commutative. Put those -4s together. Put those 4s together, -4 and +4. That equals 0. 4b is left, and then 4b is what you have there. Okay, so of course all of these are using the additive inverse and the additive identity property of 0 to get that final answer. Okay, so they're all explained that way. As long as you can explain that come assessment time, that is fine. If you want to practice it here, I highly recommend you do. But if not, then I can't stop you from not doing that. Okay, but it's good to have practice in writing out all of the steps. Again, just taking the statement, writing the sum. That's what it looks like. Okay, and then just grouping these, any order, any grouping idea. Just getting those 3x's together, the -3x and the 3x, and then of course the additive identity property of 0. Same here, just a little difference in here is that we are looking at the opposite of the 4x, which is negative 4x. Over here it was the opposite of 10t, with negative 10t, which is 10t. In E it was the opposite of negative 7 minus 4v, which is this right here, which is the opposite of, by putting the negative sign outside of the parentheses, and then going ahead and distributing, okay, and multiplying that negative 1, which is that negative sign stands for, and by both of those terms, and then you'll end up with this, and then of course doing all your regrouping and additive identity property. Okay, so again, the answer to these problems, easy enough. The process is what I want you to practice with. Okay, we'll go ahead and do these problems. Example 2 here, they should look very, very familiar to you, and go ahead and complete those, and we'll come back and discuss. Well, that probably wasn't so hard, was it? Anyway, yes, of course, everything here equals 1 whole, okay, because we are multiplying what? What are these pairs of numbers called? 3/4 and 4/3, 4 and 1/4, 1/9 and 9, negative 1/3 and negative 3, negative 6/5 and negative 5/6. All of these pairs of numbers, again, are called reciprocals, okay? Reciprocals. And these are, again, a term, very important term. I think most of you know this term, if not all, okay? And we will, excuse me, be using that. That'll come quite handy to you throughout the rest of this year and beyond. Okay, there is another term, excuse me, for reciprocal, just like opposites were the same as additive inverse. Reciprocals are the same as what we call the multiplicative inverse, and again, we've used this before several times, okay? Multiplicative inverse. These two terms here are synonymous, we say. They are the same, okay? And so when you are, if you are converting an expression, or one of these terms here, to its multiplicative inverse, there's one thing you do have to remember is that you know, or actually here, let's just do this way, so negative 1/3, its inverse, multiplicative inverse or reciprocal, is negative 3. It can't be 3, okay? It is negative 3, okay? So the sign always has to stay the same when it comes to the multiplicative inverse, okay? So as you can see, when it was a positive 3/4, it was a positive 4/3. When it was a negative 6/5, it was a negative 5/6. Okay, so it's very important that your sign stays the same, because what's going to happen eventually is that when you multiply any number by its reciprocal, you end up getting 1. Okay, so the reciprocal couldn't be of a different sign because your answer would end up being negative 1, which would not be correct. Okay. Okay, so let's go ahead and have you do the next. We have A, B, and C. Okay, A, B, and C here. And what you're going to do is you're going to write the product and then write the expression in standard form by removing parentheses and combining like terms. Just like you did when we were using the additive inverse. Now, of course, you're going to be looking at the multiplicative inverse. And as you can see, this first one, A, asks you to write the product, multiplicative inverse of 1/5. So please make note of that and that. So go ahead and do A, B, and C and come on back. Okay, so here we go. A, again, the multiplicative inverse of 1/5 was 5. And I went ahead and did it this way. I distributed out this way because, of course, I'm going to use distributive right now. I'm doing 5 times 2x. So I've actually illustrated that here, and then 5 times negative 1/5, which can also be shown as negative 5 times 1/5. okay? And again here, 5 times 2x is 10x, and then 5 times 1/5 is 1, okay? And 10x minus 1 is your final expression, okay? Same here, multiplicative inverse of 2, of course, is 1/2, and then multiplying 1/2 by 2x, and then multiplying 1/2 by 4, and I am left with x plus 2. And again, this is all I'm using actually distributive property, okay? Using distributive property, and also the multiplicative inverse, multiplication and multiplicative identity property of 1. Okay, and C, similar, but now it looks confusing, but it doesn't need to be, because the multiplicative inverse of that, 1 over 3x plus 5 is just 3x plus 5. Okay, putting 1 over any expression just means that the expression on the bottom in the denominator is going to be the multiplicative inverse. Okay, and then 1/3. So I wrote it this way initially, but then I changed it to look like this. Much easier to work with. Doesn't matter which order these are in. Okay, I just moved this here. Much easier to distribute. And then I went ahead and distributed, 1/3 times 3x, and then 1/3 times 5, and of course 1/3 times its reciprocal is x, and then 1/3 times 5 is 5/3. Okay, so exercise 2 is the last exercise in this lesson, and then we will close. So again, it's another exercise that's meant to be done with a partner, taking turns being speaker and writer. If you would like to do that, that would be great. If not, just go ahead and just write it down and maybe jot next to it what you're doing, or just say what you're doing out loud. Okay? So here we go, A, B, and C. Go ahead and do those, and come on back. Okay, so here we are back again. Exercise 2, the reciprocal of 3, and -6 minus 3x. Again, it went did that. So reciprocal of 3, of course, is 1/3. I went ahead and just put that expression into parentheses, and went ahead and distributed. I just want you to be clear what I'm doing in this step here. What I'm doing is I'm actually going ahead and taking them out one by one and distributing. So first I'm doing 1/3 times the -6y, and then doing the 1/3 times the -3x. Okay, so I am just taking those out and distributing those separately. It's just good to see what you're doing. Later on, at the end of the year and into next year, you may not be doing that any longer. Okay, but for now, I'd like you to see that step by step there. Okay. And then if you just multiply 1/3 times -6y, okay, 1/3 or third of 6, of course, is 2, so that's -2y. And then, of course, we have 1/3 times -3x is -x, okay? And then we can finally write it like this here, -2y minus x. B, multiplicative inverse of 4, which is 1/4. Okay, multiply that by this entire expression here. Distribute it out, 1/3 times the 4h minus the 1/4 times the 20. And 1/4 times 4h, of course, is just h. And then 1/4 times 20 is 5. And then that's a -5, of course, so h minus 5. Final answer. Okay, finally, multiplicative inverse of -1/6. And remember, -1/6 is going to be a -6. Okay? And then 2 minus 1/6j in the parentheses. Distributing those out. -6 times 2 plus -6 times -1/6j. And then you end up with, of course, -6 times 2 is -12. And then -6 times a -1/6j, a negative times a negative, of course, it's going to be a positive j. So that'll be your final answer there. Okay, so in closing, a few closing points. The additive inverse, which is something, a term we'll be using pretty much exclusively, is also known as opposites, okay, which is a term we used more so beforehand. And then multiplicative inverse is also known, or AKA, also known as reciprocals. Okay, reciprocals is a term that we've used for a long time, or you guys have used for a long time in math, especially in terms of fractions, of course, which is where they are absolutely applied. Okay, again, remembering the additive identity property of 0 states that 0 is the only number that when added to another number is that number again. Okay, so 0 is, it becomes more useful in the future, and you'll see how it becomes useful. But for now, it sounds like we're stating the obvious. You add 0 to a number, it stays that number. Okay, but 0 is that only number that can do that. Multiplicative identity states that 1 is the only number that, when applied to another number, is the results in that number again. Okay, so adding 0 makes a number stay the same. Multiplying by 1 makes that number stay the same. Okay, so these identity properties, the additive identity and multiplicative identity, are very important. Okay, identity and then multiplicative identity, very important. Additive identity is adding 0 plus 0, and then multiplicative identity is multiplying by 1. Okay. All right, and again, these are properties which will come in handy later, okay, and when you apply them, okay. Alrighty, well, that was a quickie, and I'm real happy to have made it quick. And go ahead and do your problem sets at exit ticket, and you are ready for the next lesson.